Friends, today we are going to discuss how to increase the compressor efficiency, how we can improve the compressor efficiency. So this can be done in several ways. One is the improve the suction conditions. Suction conditions means the compressor work best when the inlet gas is in the right state. Right state means if we get the compressor fluid at a low temperature, which means the reduced specific volume and allow the compressor to deliver higher mass flow with less energy input and prevent and that also prevent overheating. So by lowering the suction temperature, higher mass can be introduced and with lower energy input and prevent overheating also. Increase suction pressure. If you increase the suction pressure, then compression reduces the compression ratio because P1 has increased, P2 remains same. So the compression ratio will reduce, and when the compression ratio will reduce, work done will also reduce. So how we can do that? How we can do the compressor pressure increase? Now by cleaning, you use clean dry gas, avoid moisture and dust. In the separator, we are using demister pad, etc. So periodically to clean the demister pads and the moisture separated there, we can use a very good moisture separator that will remove the moisture from the fluid, and that will improve the suction pressure. The ensure filter are clean and suction lines have very minimum restriction and reduce pressure losses. How will suppose pressure loss forces the compressor to work harder if pressure drop is more. So minimize the losses of the suction and discharge pipings. By how? By avoid unnecessary bends. Where short radius bends, we can use long radius bends. Valves, they are not necessary. We avoid using any valve. And restriction is there to avoid it. And keep the intercooler and aftercooler clean. That is very important. If the fouling is there in the exchangers, then your pressure drop will be there. Even a small pressure drop increase can significantly raise the power consumption. So this is the three-way suction conditions means temperature, reduce temperature, increase suction pressure, and reducing the pressure drops. We can increase the compressor efficiency. Now, optimize the compression process. That is, we have to try. Efficiency mostly depend on the thermodynamic path. That is, our aim for compression close to the isentropic process, but there should not be any heat losses in the compression process. So, better insulations in the pipelines are very important. So, there should not be any heat loss. Maintain heat loss, and we have to clean the intercooler and for multi-stage compressor, cooling gas between stages reduces the work input. The ideal condition is to bring the temperature close to the suction temperature. This directly lower the power consumption and improve efficiency. Discharge phase temperature is high when discharge compression is high. So you cool it and try to bring when you go to next stage to the suction temperature again. That will improve the compressor efficiency. Now, compressor efficiency can also be done by using 3D impeller or LSD diffuser can improve the compressor efficiency. Normally the plain straight blade, radial blade, and simple diffuser leaves lot of efficiency. Compressor leaves lot of efficiency on the table. Modern machines gain efficiency mainly from the better flow control inside the impeller and diffuser. That exactly what 3D impeller and LSD diffuser do. What is 3D impeller? Now 3D, three-dimensional, it is called 3D means three-dimensional blade design. What is the difference with normal type? Now instead of simple 2D and radial 2D type impeller having the radial blades, and 3D impeller has blade lean forward and backward. It is starting and starting of the half and ending of the tips. It is forward and backward leaning will be there in the blood veins. So and blood veins, and that how it improves the efficiency, reduces the flow separation. If you are using simple radial, then there will be flow separation at inlet and outlet. Conventional blade, flow separation near half and shrouds, inlet and outlet. And 3D shapes are blade shapes are like that. At inlet and outlet, there will be less separation will be there, less turbulence will be there. Therefore, higher efficiency will be there. Better velocity distribution. Velocity distribution will be better from the half, then middle, everywhere curvature is there, and at the tip to avoid high losses at impeller exit also. So it is three-dimensional type impeller if you use. Then you see at the inlet of the half it is also bent, then it is totally not radial, then also it is bent at the middle, and at the A also exit also it is bent like this. So when it this it there will be no separation, no separation will not be there. Inlet also tangential, outlet also tangential, so there will be very less separation, and turbulence will be there when the gas passing through these passing through these veins of the impeller. So now the modern urea plant, if you see when the in capacity increase from 9,900 metric ton per day to 2250 metric ton per day. So design CO2 compressor design with involve at 160 kg pressure, at 160 kg pressure. So that is only possible, has become possible by using efficient 3D impeller and 2D impeller also, and high head coefficients with high head coefficients, and LSD, low density low solidity vein diffuser type vein diffusers, that made possible to now making the now modern urea plant, which has capacity increase from 9,900 metric ton per day to 2250 metric ton per day, and that is possible with how much with two barrel type compressor and 2 MCL and 2 BCL. So there is no long chain of compressors stages are not there. So with two compressor barrels, within two we are reaching the increasing the pressure from 1 to 165 kg per centimeter square, and minimize impeller internal losses, impeller external losses when half and shrouds, diffuser and vein losses. Diffuser also there is, we are using vein diffuser. There also losses will be exist. Diffuser losses will be less, and exhaust losses will also be less, and higher Mach number of fluid can be introduced. Can be introduced in the impeller. And what is the that is the called a high head coefficient 3D impeller, 2D impeller with high head coefficient. High head coefficient means it is it is a dimensionless value, that is polytropic head divided by peripheral velocity. That is peripheral velocity. This value should be between 48 to 0.54. If you are keeping in this, the efficient, the losses through the losses, centrifugal compressor is a ratio between impeller tip speed is this characterizes energy transfer capability of an impeller, and independent of that is also gas type and speed. So if you are using the high head coefficient, means point between 48 to 0.55, 0.48 to 0.55, that is called the polytropic head by your tip speed. Tip speed, if it is if the value is coming in this range, then this 2D impeller with high head coefficient also can be used. And next is improving compressor efficiency by LSD diffuser. I've told LSD diffuser also. Where what is LSD diffuser? Now is vein, there will very thin veins will be there at the diffusers. it is called low solidity vent diffuser. So there will be when there will be fewer vents, so less surface contact will be there, so less friction loss will be there, and there will be this type of flow stability will be flow stability will be there, and compressor will not stall, and LHD diffuser allow more tolerance for flow tolerance, and tolerance separation will not be there, as well as the surge margin will also increase. So LHD vents are it is called the that is low solidity vent diffuser, where thin vents are used, and number of vents are very minimum, so friction losses, the fluid come in contact the vent will be less, so that with this we can improve the losses, and the stalling which was there in the earlier due to higher number of vents, and surging, a very good surging can be margin can be achieved if you use LSD type diffuser. Then the compressor efficiency can also be increased by minimizing the clearances between interstage seals. You see that is the interstage seal of the shaft seals between two stages. We are using this type of seals, this type of groove. This is the straight labyrinth seal. This is the stepped labyrinth seals. If you are maintaining a very less clearances, so losses through the labyrinth seals will reduce, and then your efficiency will increase. So these are balancing, and labyrinth seal also used in balancing drums also. So they are the clearances we have to maintain as per the protocol value. If you are maintaining the clearances as per the protocol value, then your efficiency of the compressor will increase. I think I have discussed how you can increase the efficiency of compressor by using 3D and LHD vents, by increasing the decreasing the suction temperature, increasing the suction pressure, and in by reducing the interstage pressure drops, and pressure drop, and make the and cleaning the pressure drop in the inlet and discharge line, and cleaning periodically the demister pads, and using high quality moisture separator, moisture traps, so that no moisture can go inside the compressor, and with this we can improve the compressor efficiency. If you go through the slides, your concept will clear. If you still have any doubt, you can mail me or talk to me.